the work that is done by a constant force. When I say, yes, he has done an exclusive work, which is also called dot product of two vectors. The body is not displaced. Then you say there is no work done. What is the meaning of that? That means he can perform more amount of work. Hello students, this is SD Sir again from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. A new chapter, new thinking, new curiosity. This chapter, I will be discussing the consequence of whatever you studied earlier in mechanics. So, the chapter involves the discussion of topics related to work, power, and energy. A very fundamental terms that you have come across in your academics: work, power, and energy. So in my today's session, we will have a brief thought as to what work is, applications of the quantity called work, and introduce ourselves to call as energy. Now, dear students, I walk 5 kilometers from my home to college. Am I doing any work? Answer later. Next, I apply a force of 5 Newton. Am I doing any work here again? Curiosity, hold it up. So, this particular session, I will clearly describe as to what work is, when work is set to happen, and so on. Now, before we understand the notion of something called as work, something called scalar product or dot product, we will discuss the scalar product of two vectors, which is also called dot product of two vectors. So, I am trying to introduce a mathematical operation where I multiply two vectors using the scalar product method or dot product method. Deep into that discussion will be done in your second PU, vector algebra. Here, superficially, I try to understand the scalar product or the dot product method. Now, I have two vectors, vector A and vector B. I consider two vectors. One is vector A and the other is vector B, which is inclined at an angle theta. So theta is the angle between vector A and vector B. Now my intention is to multiply these two vectors by using scalar product method or dot product method. Follow carefully. So we write this as vector A dot vector B. This is dot product multiplication of two vectors, which is also called the scalar product. So vector A dot vector B. This is defined as the magnitude of vector A into magnitude of vector B into cos theta. It is cosine of the angle between the two vectors. Dot product defines the multiplication as vector A dot vector B, which is magnitude of vector A into magnitude of vector B into cosine of the angle between the two vectors. So we have written vector A dot vector B is vector A magnitude of vector B cos theta. Please do remember, first registration in your mind, wherever you have dot product of two vectors, it is cosine. I repeat and highlight again. It is cosine of the angle between the two vectors. Therefore, here vector A dot vector B is magnitude of vector A is A. Magnitude of vector B is some B cos theta. So we have vector A dot vector B is A B cos theta. ನೀವು ಇಲ್ಲಿ ನೆನಪಲ್ಲಿ ಇಟ್ಕೋಬೇಕಾಗಿರೋದು ಏನಂದ್ರೆ, this A and B vectors cannot be zero. They are terms within magnitude, mod symbol ಅಂತ ಕರಿತೀವಿ. When you are defining it saying magnitude of vector A, it has a specific value. Magnitude of vector B, it has a specific value. A and B cannot be zero. So dot product of two vectors is defined as vector A dot vector B equals magnitude of vector A into magnitude of vector B into cos theta. A more clinical, physical example for dot product, which is the definition of work itself. The first concept that we study, that we understand in this chapter is the definition of work, where we say work is nothing but force into displacement. This is the more mechanical definition of work. Work is force into displacement, the product of force acting on a body and displacement caused is called as work. Therefore, I write W is vector F dot vector S. Displacement I have called S. Force and displacement are both vectors. So vector F dot vector S, or this can also be written as F S cos theta. So work is defined as the dot product of force and displacement. Vector F dot vector S, or W is F S cos theta. My dear students, the most interesting thing here is, look at the left hand side, work. Dear students, work is a scalar. I am multiplying two vectors using dot product method, and the result I get is a scalar. Beauty. So always remember, the result of dot product method, quote this, when two vectors are multiplied using dot product method, the result we get is always a scalar. Similarly, we also define cross product. This you study deep in math. A cross B. Just now know this is vector A, magnitude of vector B into sin theta. This is multiplying two vectors by cross product method, and here the result is always a vector. So dot product multiplication yields a scalar. Cross product multiplication will yield a vector. Now, my basic question before was, here is a wall and a man who is pushing the ball, applying a force of 10 Newton. Gode ಇದೆ. The person is pushing the wall by applying a force of 10 Newton. Can I say, yes, he has done an exclusive work? No. Why? Sir, he is pushing the wall. He is applying 10 Newton force. Yalla sari. Adre yelli displacement ide. There is no displacement here. If the body is not displaced, then you say there is no work done. You may apply any magnitude of force. For work to happen, there has to be some displacement. So please do remember, without displacement, we never say that work has taken place. Good. Now we define the SI unit of work. Which is the SI unit of work? The SI unit of work is joule. So joule is said to be the SI unit of work. Now, when do you say a body is performing 1 joule of work? Under what conditions do I comment saying that 1 joule of work has happened? For that, we use the definition of work, where F, yes, cos theta. This is the dot product expansion of work. F, yes, cos theta. Now my question is, when do you say 1 joule of work has happened? For that, all the terms on the right hand side should be unity, which means force acting on the body should be 1 Newton. Displacement caused should be 1 meter. Theta should be 0 degrees so that cos 0 is 1. So force has to be 1 Newton. Displacement has to be 1 meter. Theta has to be 0. Then W is 1 joule. So put all these terms in physical statements. Work done is said to be 1 joule if a force of 1 Newton applied on a body causes a displacement of 1 meter. Force acting on the body is 1 Newton, causing displacement of 1 meter in the direction of force, and that is what is called 1 joule of work. It is force of 1 Newton acting on a body, displacing it through 1 meter. 1 Newton force apply ಮಾಡಿದಾಗ a body 1 meter distance ಅಲ್ಲಿ ಡಿಸ್ಪ್ಲೇಸ್ ಆಗಿದ್ರೆ ನಾವು 1 joule of work ಆಗಿದೆ ಅಂತ ಕರಿತೀವಿ. So this is the basic definition for work. Now, dimensional formula for work, we will work it out. So, work dimensional formula is force into displacement. So this is how I have defined work. F dot S, force into displacement, force MLT minus 2, displacement is L. So this is M L square T minus 2. This is the dimensional formula for work, and the SI unit for work is joule. This is the common accepted SI unit, joule. So force into displacement, M L square T minus 2, Joule is the followed SI unit. It is also kg meter square second minus 2, but we don't follow this rigorously. The commonly used SI unit is joule. Now, we will study work done by a constant force, and this is studied by plotting something called force displacement graph. Work done by a constant force. When I say constant force, the magnitude of the force remains same. So work done by a body under a constant force AB, displacement along x-axis, force is applied along y-axis. Now the area of the force displacement curve will give me the work done by the body. So we write work is the area under this AB, OA into OC. So it is F dot X, or displacement, what is called as S. So if you observe, I repeat again, we are calculating the work that is done by a constant force. Magnitude of the force acting on the body should be the same. I use a graph called force displacement graph to calculate. X-axis ಅಲ್ಲಿ displacement mark ಮಾಡ್ತೀನಿ, y-axis ಅಲ್ಲಿ force mark ಮಾಡ್ತೀನಿ. Area of this graph gives me work done. So what is area here? OA into OC, or strictly speaking, W is F dot S. So this is the work done by a constant force whose magnitude remains the same throughout, and it is always calculated from the area of force displacement graph. 1 mark ಯಾವಾಗಲೂ ಕೇಳ್ತಾರೆ, what is the significance of force displacement graph? It gives the work done by a constant force acting on a body, and this is the work done by a variable force. When I say variable, here magnitude goes on changing. Okay, so magnitude goes on changing. Simple to understand. This is an integration symbol. This means to say the total work done by the force is within the limits x1 to x2. This is called initial limit, lower limit to upper limit. This is the work done. Okay, that means I am stripping x1 plus x2 plus x3, etc. So starting limit is x1, ending limit is x2. Within this boundary, you can observe here, whatever work is done, dW, This dW is force into displacement. This is work done by a variable force. Now, with whatever understanding we have about work, we say, or we try to define what is energy. He's very energetic. What is the meaning of that? That means he can perform more amount of work. Come on, he's a dumb. He doesn't have energy at all. ಏನ್ ಹಾಗಂದ್ರೆ ಕೆಲ್ಸಕ್ಕೆ ಬಾರ್ದವ್ರು ಕನ್ನಡದಲ್ಲಿ ಬೈದ್ಬಿಡ್ತೀವಿ. That person cannot perform any work. So, what is energy? It is a measure of work done. So, we say capacity of a body to do work is what is called energy. So, we are measuring energy as, yes, capability or capacity to do work, the degree to which one can perform work is called energy. Now, there are two types of energy a body can possess. One is called kinetic energy and the other one is called potential energy. Two types of mechanical energy can be possessed. The first one is called kinetic energy. The other one is called potential energy. Now we will speak about kinetic energy. The moment kinetics comes into picture, it means motion is coming into picture. So the energy possessed by the body because of its motion, or I can say because of its speed, is what is called kinetic energy. Or in simple words to understand, any moving body possesses kinetic energy. So it is by virtue of motion, because of speed, that is what is called kinetic energy. And expression for kinetic energy, nothing new, all that you have studied earlier, half mv square. This is the expression for kinetic energy, where m is the mass of the body, v is the velocity of motion. And few examples or description for energy. As I told, it is the capacity to do work. Again, the SI unit of energy is joule. It has the same dimensional formula as work. So somewhere they are connected. Therefore, I told energy is the measure of doing work. ml square T minus 2. Is the CGS unit of energy, and 1 is 10 power minus 7 joules. Nuclear units of energy is electron volt. 1 electron volt is 1.6 into 10 power minus 19 joules. And few examples for kinetic energy. As I told, any moving body, wherever velocity comes into picture, we have kinetic energy. Flowing water, moving car, bullet fired from a gun, blowing wind, all of them possess kinetic energy. virtue of motion because of velocity. So students, in this session, we had a skeletal outlook as to what is work, how the force displacement graph helps us to calculate work in case of constant force and variable force. What is energy as a measure of work? We spoke about kinetic energy and examples. The next session, I come with a more prestigious concept called work energy theorem. Until then, have a revision on this session. Thank you.